Hello viewers, welcome to my channel, Sir King Math Hub, the solution to your math problems. We are still on bearings, but this time we are going to look at distance bearing problems. Distance bearing problems. So the bearing between 2 points or 2 towns or 2 locations will be given, as well as the distance between these 2 points. That's why we call it distance bearing problem. So there's our first question. An aeroplane flew from town A, travels 200 kilometers at a bearing of 135 degrees to town B. So the first information should be able to represent this with a diagram. So let's quickly do that. So we've been given 2 towns here, town A and town B. So between town A and town B, where are we supposed to measure the bearing of 135 degrees? So again, we said that in bearings, this is the key word, from town A, from town A. So from town A, we should measure a bearing of 135 degrees. So let's do that. So here is our town A. And since this is a 3-figure bearing, we said that angles are read from the geographical north in the clockwise direction. So from north to east, that is 90 degrees. So clearly we see that 135 degrees will be in this quadrant. So 90 degrees plus what angle should give us 135 degrees. So let's put on our thinking caps. 90 degrees plus what angle will give us 135 degrees. So clearly that is 45 degrees. 45 degrees. So 45 degrees. So this angle here should measure 45 degrees. Which town should be here? Which town should be here? So it flew from town A to town B. So here is town B. So we can name here as town B. What was the distance between town A and town B? So it travels 200 kilometers from town A to town B. So it means that the distance between town A and town B measures 200 kilometers. So we are done with the first one. Now the second statement, it then travels 250 kilometers from town B. So from that is where we have to draw. So from town B at a bearing of 45 degrees to town C. So it means that from town B we have to measure a bearing of 45 degrees. So from town B, we have to measure 45 degrees to town C. To measure so from the geographical north in the clockwise direction. So this angle here should also measure 45 degrees. So which town should be here? So obviously here should be town C. And what was the distance? So it then travels 250 kilometers from town B at a bearing of 45 degrees to town C. So this distance here is 250 kilometers. So that is what we have done. So what shape are we seeing? See that we are getting something like a triangle. So how then do we get a triangle out of this shape? So we need to join these 2 points, point B and point C. We need to join them. We need to join these 2 points. So we have done that. We have joined the 2 points. So as you can see, we are seeing a triangle. We are seeing a triangle. And as I've been telling you, since this is core math, in most cases, one of the interior angles must measure 90 degrees. So let's go and look for that particular interior angle. So now, let's consider this quadrant. This quadrant here. We know that the total measure of a quadrant is 90 degrees. Now, this quadrant has been divided into 2. One part measuring 45 degrees. So what angle should be here? So clearly here 2 must measure 45 degrees. And do you see alternating angles? Angles formed from the alphabet Z. Alternating angles. We know that alternating angles are equal. So if this angle here measures 45 degrees, then clearly this angle must also measure 45 degrees. So clearly this interior angle here measures 90 degrees. Or 45 degrees plus 45 degrees, that should give us 90 degrees. That should give us 90 degrees. So we now have our 90 degrees angle. So we can conclude that this is a right angle triangle. This is a right angle triangle. Now, what are we looking for? We are to find A, the distance of A from C. The distance of A from C means that we have to calculate this length. The length of line AC. The length of line AC. So as you can see from this triangle, so I'm naming this triangle ABC. Triangle ABC. Triangle ABC. We see that triangle ABC is a right angle triangle because one of the interior angles measures 90 degrees. And because there is a right angle triangle, to calculate line AC, we have to go by Pythagoras theorem. So from Pythagoras theorem, so we are solving the A. There is the longest side because it's the side facing a 90 degrees angle. So we know that the squared of the longest side, in this case line AC squared, should be equal to the sum of the squares of the other 2 sides. So this side here measures 200 kilometers. So 200 kilometers squared plus the other side 250 kilometers squared. So let's solve for AC. So AC squared is equal to, what is 200 squared? 200 squared. That is giving me 40,000. And then 250 squared. 625,000. So we have AC squared is equal to 40,000 plus 62,500, and that is giving us 102,500. We are looking for AC, not AC squared. We are looking for AC. We are looking for AC, not AC squared. So we have to take we can take the square root on both sides. So the square root and the square will cancel out, leaving AC is equal to square root of 102,500. So 320.16 to 2 decimal places. So AC is equal to 320.16 kilometers. So that is the distance of A from C. 320.16 kilometers. So that is what we have done. Now, the B part, we have to find the bearing of A from C. The bearing of A from C. The bearing of A from C. So, can we identify that? The bearing of A from where? So it means that we have to measure the bearing from C. So this is C. So for three-figure bearing, angles are read from the geographical note. The bearing of A from C. So it means that starting from C until we get to the line connecting town A. So from the geographical note, we move until we get to the line connecting town A. So how then do we calculate this bearing? We know that the measure of the angle here is 90, here is 90, here is 45. So we need an interior angle here. So let's represent the angle here by theta. So first of all, let's calculate theta. So how then do we calculate theta? So from trig, we need to identify the sides of this right angle triangle. You see that there is a right angle triangle, but this theta here is facing this side. So this side here becomes the opposite. And then the longest side is the hypotenuse. Again, the longest side is the side facing a 90 degrees angle. And then obviously, this side here will be our adjacent. So to calculate this theta, we have our opposite, we have our adjacent. So we have our opposite, we have our adjacent. So from SOHCAHTOA, which of them has opposite adjacent? So clearly, that is TOA. And what does TOA say? TOA says that the tan of the acute angle here, which is theta, should be equal to the length of the opposite. So this side is the opposite. It measures 200 kilometers divided by the length of the adjacent. So there is the adjacent, 250 kilometers. We are looking for theta. So what do? We take the tan inverse on both sides. So when you take the tan inverse of tan theta, the tan and its inverse will cancel out, leaving theta on the left. Then we have tan inverse of 200 divided by 250. So from our calculator, what is the tan inverse of 200 divided by 250? So theta is 38.66 degrees to 2 decimal places. 38.66 degrees. So finally, so this is our B part. Don't forget, this is our B part. Finally, the bearing of A from C. The bearing of A from C. The bearing of A from C. So from the diagram, the bearing of A from C. So it means that we have to start measuring the angle from the geographical north in the clockwise direction. So from the geographical north to the east, that angle there measures 90 degrees. From east to south, 90 degrees. What angle is here? So as you can see, if this angle here measures 45 degrees, then obviously this angle will also measure 45 degrees, because these two angles are alternating. They are alternating, and we know that alternating angles are equal. So here is also 45 degrees. So plus 45 degrees, and then finally plus the angle theta. What did we get for theta? We had 38.66 degrees. So what is our final answer? So let's do that. 90 plus 90 plus 45 plus 38.66, and that is giving us 263.66 degrees. So that is the bearing of A from C. The bearing of A from C measures 263.66 degrees. I hope you enjoyed this lesson. See you next time.